smoothing by a capacitor. The basic issue was fluctuation in the rectified DC. They thought of using a capacitor, and the capacitor is on charging in the forward bias. In the reverse bias, the capacitor, there is no current from the back. The capacitor discharge and give current to the resistor. The capacitor charges when the diode allows current to flow and discharges when the diode does not allow current to flow. I think we made this diagram that in the forward bias, capacitor is charging. In the reverse bias, capacitor is discharging. And we made this idea that capacitor is a smoothing device component. We made this diagram a very important sketch. It has appeared in the exam many times. The time constant dependent on the load resistor and the capacitance of the capacitor is linked to the time frequency of AC. So this will be our first concept. The time constant, which depends upon resistance and capacitance, is determining the time frequency of AC. Alternating current is very important in terms of frequency. Frequency is the major factor for AC. Normally in Pakistan and many countries like here, we have 50 to around 50 hertz. In some areas, it's up to 60
Sir?
hertz. Hmm?
Sorry, but the last heading we gave was bridge rectifier. We were supposed to start that. We did discuss time constant. We wrote greater the value of time constant, greater is the degree of smoothing.
We gave the heading bridge rectifier.
Yeah.
Have we discussed full wave rectification, like if it is full wave rectified like this diagram? It is full wave rectified and smoothing is done by a capacitor.
Yeah, we did copy a diagram for that. Yeah.
Okay, good. So double check and so we were here.
Yes, sir. We just wrote the heading.
Then mark it the most important topic. This is the main topic of this chapter. This chapter does not come every year. AC circuit is not an every paper chapter, but whenever it comes, bridge rectifier is the most important thing. Initially, they tried with one diode, but this circuit got very successful worldwide. And here they thought about using 4 diodes. I have shown the circuit, and I have shown 2 diodes red and 2 diodes I have shown blue. Look at the direction, look at the marking A1, A2, A3. What you do, you first copy this diagram, then the discussion would be easy.
Done, sir.
Let's get the current from the top. let's get the current from the top, and when the current is coming from the top, look, this is the current coming, and the current reaches position A. Now D1 will allow the current and D2 will refuse because it's reverse bias. Thin line is the high resistance one. So current will go through this diode and reach position B. At position B, D4 will refuse because of the low terminal, high resistance terminal. So current will go through the resistor R. It reaches point C. When it reaches point C, the diode D2 will allow it to go. Then the current reaches position D, and then the current goes forward like this and complete the cycle. In one direction, current passes in this route. Now current comes from the other side. This is how AC works, AC reverses. This current reaches position D. D2 refuses, and the D4 allows the current. So it will enter the diode, reaches here, reaches position B. When it reaches position B, D1 will refuse. It goes to resistor R, reaches position C. Then it goes up, go through the D3, reaches position A, and then it travels forward, and then it completes the circuit. Now, this is the smartness of this circuit, that the resistor, if you look at the resistor, is it right to say that for the resistor, current is not switching? For the resistor, is it right that the direction of current is not changing?
Yeah, it's not changing.
So this is a tricky, very smartly made circuit, that for the resistor, direction of current is not changing. For the resistor, direction of current is not changing. Look at the screen like this, then like this. So if the current keeps on switching, current will switching through the circuit, but the resistance will not feel any change. For the resistor will feel that the current is in one direction. This is like a DC. So this is a smart circuit which allows the current in one direction for the resistor. The resistor will receive the current like this. This is called full wave rectified DC. This is the output, and this is called full wave rectified DC. So after copying the diagram, these are the 4 diodes. Now write under it that at a time two diodes are conducting. At a time, 2 diodes are conducting while the other 2 are not conducting. Now look at position A. When current enters from junction A, look at the junction A. D D1 and D2, the red ones. D1 and D2 are conducting. D1 and D2 are conducting. D3 and D4 are on reverse biased. So when you look at the circuit, this is the resistor, the load resistor. Now for the load resistor, current passes in this direction. You have to copy this.
Done, sir.
Now we make the second pair when current reverses. When AC reverses, and current enters from junction D. Look at the diagram. In that case, what two diodes are conducting?
D3 and 4.
D3 and D4 or D3 and D2? The blue ones.
The conducting ones are D3 and 4, right?
Yes. When it is coming from the back, the conductivity is for D3 and D4, the blue ones. But definitely in the notes, the blue color could not be copied. So we marked it D3, D4. And in that point, D1 and D2 are on reverse biased. Current is going through the same path, same direction.
Done, sir.
This is called half wave rectified DC. The output is half wave rectified DC. This is the current. And using 4 diodes, you will get half wave rectified DC, and then this is a circuit. After rectification, you can use a capacitor in parallel. You can use a capacitor in parallel to smooth the output DC, which is the full wave rectified DC. So after the full wave rectification, we need to use capacitor again. So either you come from half wave rectification or full wave, you have to put a capacitor in parallel so you can use it for smoothing.
While flowing from a generator to a light bulb, the alternating current encounters a diode. The diode allows current in one direction only, which is represented on the oscilloscope as a voltage against time graph, with the bottom halves cut out. When the diode is reversed, the top halves of the graph disappear. In both cases, the current does work in the light bulb, through only half the illumination time. In order to convert alternating current into direct current, a system of 4 connected diodes is commonly used. During the first half of the period, current flows through diodes 1 and 4. When the voltage due to a generator changes its sign, diodes 2 and 3 start to conduct the current. Such a solution makes it possible for the current to flow through the light bulb all the time in one direction. A system of 4 diodes converts the alternating current into pulsating one-directional current. A capacitor, which is connected in parallel to the system of diodes, becomes a kind of buffer. When the voltage is high, it accumulates charges, and when it drops to 0 for a while, it becomes a source of voltage. When the capacitance of a capacitor is high enough, the current obtained becomes practically direct current, and not only one-directional current. While flowing from a generator to a light bulb,
Some cases we use a transformer before the bridge rectifier. Definitely transformer is not our requirement now, so we do not consider it, but the circuit is working like that. This is a circuit of the bridge rectifier, and we attach a capacitor. In parallel to smooth the output DC. So when we use capacitor, we can get an output of smooth DC. So after copying that circuit, after copying that description, this one, you have to write under it that the output is full wave rectified DC. You have to copy this screen. Have you copied it?
Yes, sir. Done.
Good. Now, this is the output, and again, this is not a full supported current. This is not a current which can be full supported it. And right under it that this is not the full, this is not the fully steady current. This is not the fully steady current. So we need to use a capacitor. We need to use a capacitor. So right under it that a capacitor is now used. A capacitor is now used in parallel a capacitor is now used in parallel in order to obtain a smooth current in order to obtain a smooth current now you have to copy this diagram neatly. I'm just coming. I have to say, Namaz, I'm just coming. Please copy this. After the introduction of capacitor, what will happen that the capacitor, as discussed earlier also, capacitor offers smoothing by charging and so you have to copy this screen. Let me know once you have copied it.
Done, sir.
So we made this concept, and now it is, I hope it is clear to you that it has to be done. Either you are coming from full wave rectification or you are coming from half wave rectification. So here we have a diode. We get full wave. This is called bridge rectifier. Now bridge rectifier with one capacitor and bridge rectifier with two capacitor. So you can see here that we are using a bridge rectifier. But there is no capacitor. Now you can see as the number of capacitor increases, what happens as the number of capacitor increases, the degree of smoothing increases until you can get a very smooth, nearly steady current. So you have to write under it. Write under it that as the capacitance time constant tau increases. Degree of smoothing increases. So it means if you use a big capacitor of high capacitance, the output is very smooth. Even it can be a steady output. Now you have to give a heading, formulas. This chapter is finished. So now you have to give a heading, formulas. Copy this screen.
Done, sir.
E is equal to 1 upon F. Theta is equal to omega T. These are the two general equations. And then comes the subsidiary I and V equations, time equation, RMS. These are the two main formulas.
Done, sir.
Mean power and the other powers losses are there. You have to copy these formulas.
Done, sir.
Good. Then you have to copy these formulas.
Done, sir.
Okay. Then this formula.
Done, sir.
So this chapter has finished. And you have to change the page. You have to change the page and give the heading Quantum Physics. This will be our new chapter.
Sir, are you sharing some?
Actually, I lost the screen and I'm trying to get it back. Quantum Physics. This is our next title chapter, and it is part of a physics called Modern Physics. So change the page and give this heading We first put the introduction. There are two main physics. Nowadays, many people are talking about quantum physics, and quantum physics in our latest movies that got a big fame, especially the fiction things which were fiction in near time, but now people are saying is getting real, about black holes, about multi-universe, multiverse, and many things are there. Quantum physics is actually dealing with the many mysteries of science. How it started, we go back in our past and we see that there were two physics actually. One is Einstein work, which we call modern physics, and second is Newton work, which we call as conventional physics. So you have to give a heading and give heading introduction and then copy this.
Done, sir.
There are two physics. Conventional physics, give the heading conventional physics. Conventional, the word conventional means Newton physics. Newton was the main person there. He developed a huge mechanics, gravitation, Newton laws, then also the work energy power, forces, upthrust, dynamics, kinematics. These were called Newton mechanics. Then Huygens was a person and his fellow people, they developed a huge section of waves. Now, these were two things which collectively called conventional physics. You have to copy this.
Done, sir.
Good. We were having concepts of reflection. Can you identify this AS famous concept?
Is it diffraction?
Yes, it is diffraction. Very good. Identify this. The famous fringe pattern,
Interference.
interference and diffraction. The waves properties. Newton had a belief that there are two entities in this universe. Newton had a belief that there are two entities in this universe. One is mass and second is energy. So he had a view that there are two separate characters. One is called a particle character and second is called a wave character. This is a very interesting, very high level discussion. And this is where science actually reaches a new horizon. When Einstein, he was a simple person, not a big scientist, not a big name. He challenged Newton's fundamental theory, the main theory of Newton. And Newton had a belief that particle character and wave character are different characters. He thought that wave particle character is coming from mass and wave character is coming from energy. So he thought that it is not a sensible question to ask someone, what is your wavelength? Even now, if you ask someone, what is your wavelength? It will appear to be a silly question. But when you're sitting in a car and you're listening a radio, people use the word FM 100, which is frequency, that is a wave character. People talk about the mass of a person, weight of a person, density of a ball, and these were so established facts that actually Newton thought that these are unbreakable concepts. The problem came, and Einstein was the first person, then also some other people who challenged this thing, and that started a mystery that actually what is a particle and what is a wave. So that is called the competition between two dynamics of physics. But you first you copy this.
Done, sir.
Now copy this.
Done, sir.
So I hope you got the primary idea. So Newton was confident and he made a line drawn between two characters, particle character and wave character. Even now, this character is a discussion, but a lot of movies have been made. And if you have a taste of watching these fiction movies, sci-fi type movies in which people talk about second dimension, third dimension, fourth dimension, multiverse, black hole, time travel, a lot of mysteries are there. So these all mysteries were originated when Newton broke this glass. It was a glass transparent concept, and people were sure that this is right. Obviously, if I ask someone, what is your frequency? He say, I can't have a frequency. I am a person. I am a mass. Similarly, you can't look for momentum of infrared rays. But now science accept that Einstein was right and Newton was wrong. There is no line between the two characters. You have to copy this.
Done, sir.
Time is an absolute quantity. Mass is an absolute quantity. This is all part of Newton physics. Time is an absolute quantity means what? Time doesn't change for anyone. You are sleeping, you are studying, you are watching movie, whatever you are doing, time is independent. Time will be the same. Mass is a universal quantity. Unfortunately, Einstein challenged all of these things, and that was like an earthquake at that time. And some people are like that, and he shuffled all the concepts. I'm telling again because, this chapter is going to make a contrast between the two physics. You have to copy this.
Done, sir.
Now copy this heading.
Done, sir.
So we keep it up to here and we'll inshallah continue in our next class. Thank you.